session of Confectionery Live. For this session, I'm joined with Shannon Nangle from Circe Bioscience. Hi, Shannon, how are you doing?
I'm doing all right. How are you?
I'm good, thank you. Thank you for joining us and being willing to be interviewed by me for this.
Of course.
Can you just start off by introducing yourself and what you do at Circe Bioscience?
Yep, totally. So I am CEO and co-founder. I have a background in biology. I developed the technology while I was doing my postdoc at Harvard. Basically, what we do is engineer microbes to transform CO2, water, and electricity into valuable products. We're focusing on triglycerides, so all of the fats, butters, and oils found in plants and animals. With a focus on confectionery, specifically palm oil and cocoa butter substitutes.
That's wonderful. Thank you so much. Do you mind if I just jump right in with some questions?
Yep.
Perfect. Can you just explain to me how Circe's gas formation process differs from other fermentation methods used in food production?
Yeah, totally. So in traditional fermentation, you have often a plant-based feedstock that the microbes transform into either alcohol or other products. What we do is transform gases, so CO2, water, and electricity, which turns into oxygen and hydrogen, and we can feed those gases directly to the microbes that are then engineered to make specific products. So you can kind of imagine us like a soda carbonation process at the start, a brewery in the middle, and a palm oil refinery at the end. And this process is highly sustainable, almost no carbon footprint. It can be even a carbon negative process, limited water use, and minimal land use. So we can provide tailored alternatives to the triglycerides that are already in the supply chain, but with vastly more efficient resource use.
Thank you. That's really interesting. How does Circe's approach to creating fats and oils potentially impact the sourcing of ingredients for confectionery specifically?
Yeah, so specifically, if we just focus on cocoa butter and palm oil, we can think about the limited resource footprint. So deforestation is not an issue for us. There are very limited environmental and hopefully no ethical concerns with our process. We can not only reduce the environmental footprint, but in making the specific fats that are needed for the food application, we can go after much more functional substitutes that are fit for purpose for the specific confectionery application. So we can both provide drop-in, but also customized value add or highly functional alternatives.
Oh, it's incredible. Thank you so much for explaining things. I'm a bit of a layperson when it comes to these things, so I'm happy that you're here to direct me. Can you just tell me, in what ways could Circe's technology sort of contribute to more sustainable practices within the confectionery industry itself?
Well, yeah, so the big one is actually we can help stabilize the variability of supply. So if we think about a fermentation process as one that is operating 24/7, it is not prone to supply chain disruptions, as I'm sure everyone is familiar with the cacao futures event that was earlier this year. A process like ours, once scaled, will help stabilize that type of situation if it happens again. And so what we're really able to deliver is not just a functional value-added product that has minimal resource use and no carbon footprint, but really it is the supply chain resilience that we provide for the entire industry. So we can help incentivize more sustainable practices by solving for the supply chain stability.
It's really important in the confectionery sector to have that sort of supply chain stability too. Can you just let me know the advantages of Circe's process in terms of resource use, comparing it to like the traditional agricultural methods?
Well, yeah, so we don't use a plant-based feedstock for our process. So there is no land use aside from the actual footprint of the facility. And so that means no deforestation, no excessive resource use for feedstocks. And then we can recycle our water use. So that means that our water consumption is much less than the agricultural practices. We can also use renewable energy in our process, making our full facility carbon negative. And then, of course, because we are using CO2 as a feedstock, we actually just make use of the raw materials that we have here on Earth, and are using what would otherwise be a waste stream as a way to produce material. So yeah, we're significantly more stable and sustainable compared to your traditional agricultural practices.
How might Circe's technology address some of the sustainability challenges faced by the confectionery industry, especially when you're sourcing palm oil, as you mentioned, or cocoa butter?
Yeah. Well, so like I mentioned before, the industries of cocoa butter and palm oil significantly drive deforestation and biodiversity loss. We can be located right next to the chocolate factory if necessary. So yeah, we are able to completely circumvent the sustainability challenges that are faced by many confectionery manufacturers. We can have, as I mentioned, the extreme resource efficiency that is enabled by our process. We are also able to be domestically produced, so that decreases the risk of geopolitical instability. So really, it's hard to think of a sustainability or stability challenge that we don't solve for. So yeah, we're able to really provide a new and unique way of making the same products that are in the supply chain today.
And can I just ask, on another note, what kind of land does the facility take up? So what's the space of it?
Well, yeah, so a full-scale facility, which we are yet to build, is about the footprint of an ethanol refinery. So it's or a large brewery. It's a large building.
Okay, thank you. And can I just also ask, how might Circe's approach to ingredient production affect the confectionery industry's economics and the sustainability efforts?
Yeah, totally. So we've been talking a lot about the sustainability elements. What is kind of all of that really happens to be a positive externality as a result of the process that we use. So the reason that we are able to scale this technology is through the use of gases rather than plants as a feedstock. And what that enables is very low unit costs. So if we're using CO2 as a feedstock, that is either cheap to free based on our point source. And then we have water electrolysis that can make our hydrogen and oxygen. And so what that enables is a scaled process that actually can be the unit cost is less than incumbent processes, even some palm oil processes. So if scaled, our process would be less than $1 a kilogram unit cost, which would be one of the cheapest ways to make oil on the planet. So you have that as a result of the way that we've chosen to use our feedstocks and inputs. And so yeah, we recognize the challenge of being able to provide not only the drop-in ingredient, but at price parity with the current ingredients. So that's the true benefit, I would say, to the confectionery industry, is that we are we're attempting to reach price parity, and really the sustainability elements all are a kind of bonus on top of that.
Just something I'm intrigued by. You mentioned about your feedstock and carbon dioxide and water. Kind of, where does that come from? Obviously, those are elements that are around us all the time. But can you sort of maybe go into a little more detail about how it works?
Sure. Yeah. So the way to think about it is we can use the emissions, so the CO2 emissions of a process. So say an ethanol refinery on a cornfield is transforming corn into ethanol using microbes. Those microbes, like in a beer brewery, are producing CO2 as a waste product. That is a very pure, concentrated stream of CO2. Our microbes can eat that. So then we compress it, deliver it to the fermentation vessel, and then we can take water, use electricity to break it into hydrogen and oxygen, also gases, and then deliver that to the fermentation vessel as well. Our organisms can eat gases. So like a plant can eat CO2, for example, and then drink water. Our microbes do something very similar, and instead of making their natural microbe innards, we engineer them to make the specific product. So we take, say, the genes from a cacao tree, put them in our microbe. That microbe now has the capability to do the same transformations of CO2 into cocoa butter, for example. And then we can grow up those cells, harvest them, take the cocoa butter out, or the cocoa butter substitute, to be technically correct, and then we can refine it and provide a drop-in alternative. So that is the entire process.
Thank you so much. Can you? Just a couple more questions. Could you possibly share like where you see everything going with Circe, like your vision for the future, how you might reshape the confectionery industry over the next decade or so?
Well, yeah. So this is still a pretty bleeding edge technology. So we're at the initial stages. We have our pilot facility, which is one of the most versatile, powerful technologies in the world to transform CO2 into products. But we still have a ways to go. So in the next 5 to 10 years, we're all about scaling up. So that is building our next facilities, demonstrating that we can, in fact, reach price parity with incumbent ingredients. But really, what I see this technology offering is a way for us to decouple growth and production from resource extraction. So the way that we've usually maintained our relationship with the planet is to extract resources for the production of goods, and what this technology offers is an infinitely recyclable process that can transform CO2 water into arbitrary molecules, and so not only the confectionery industry, but really any industry could make use of a technology like this, and hopefully that would enable both the stability of the industries and the growth of them.
It's really exciting and honestly inspiring to sort of learn about these new technologies that are coming through that could make our world look completely different and really revolutionize what we now call sustainability might completely have been reorganized in the next 10 years, partially maybe thanks to you. So thank you. I just had one more question. So how did you come to this point? How did you sort of found Circe, and like how did you decide that this was what you were going to do?
Well,
it's a big question.
Short answer is I've always been looking to biology as a technology in and of itself. So, we kind of take for granted all of the biochemical reactions that enable our life on Earth, and just looking at the promise of using biology instead of industrial chemistry, for example, has always been a kind of utopic or inspiring way of thinking about industry. And so through my studies, I've always been a biologist, but through my studies, I increasingly focused on the application of biology in the world instead of basic research. But ultimately, I feel like technologies like this must exist for the future to enable human flourishing. So it's kind of an obvious challenge to solve.
But a very hard one. I mean, you could put me in a room with about 10 different people, and I'm sure that we would not come up with with anything close to this kind of solution for sustainability. Do you find that being a scientist and sort of like managing the company is hard? Because you must have such a technical level of expertise that explaining what you do to other people, you must find difficult.
Well, it depends who the other person is, but I would say that it is much different than doing a PhD or a postdoc or working in a lab. So there's certainly a steep learning curve, but in just surrounding myself with an amazing team and folks who have done this before, it's been difficult but enjoyable, and and something that I want to keep doing.
I just wanted to know, so the Circe team, there's you as one of the co-founders. Are you all sort of with a background of science and study?
Many of us. So our other co-founders, Kieran, he is a mechanical engineer, and then Malad, who has more than a decade of experience in the chemical industry. So he has really hands-on experience in new product development, in ingredients. And so the three of us are the co-founders, and then the rest of the team is a mix of scientists and engineers for the most part. And then as we continue to grow, we'll be bringing on more and more non-technical team.
So for now, it's a group of very smart people.
Well, scientists and engineers, but yes.
Thank you. And my last personal question, and please don't make fun of me. Can you just define what a microbe is for me, please?
Oh yeah. So a microbe is a single cell organism that is free living. It can be anything from a yeast, so the type of organisms that you use in making kimchi or wine or beer. It can be a virus, which is not really a cell, but we'll just ignore that. Or it could be a bacteria, which is what your microbiome is made out of, what is in the soil to help create a rich and nutrient dense soil for plants. But it is a single cell organism that is free living.
Thank you so much, Shannon, for taking part in Confectionery Live. I think what you're doing is really exciting with Circe Bioscience, and I can't wait. Really, when we were talking about the future, I got very excited about where you'll be in that. So thank you so much for taking the time to speak to me. I really do appreciate it.
Of course. Thank you for having me.